Welcome to my presentation. In this presentation, let us see how to find the length of a vector. In here, if u is a vector, and if the components of this vector are u1 and u2, and to find the length, then the length of the vector, the length of vector u is represented as a vector like that, and then we draw two lines on either side, and the definition of the length of the vector is we take the components of the given vector, and then take under the square root we're going to raise them to the second power, add them together and raise them to the second power, u1 squared plus u2 squared, like that. And that is the definition of length of a vector. This is read as length of a vector, the length of a vector. Okay, let us see how we can represent length of the vector graphically. So let us see that. So if we were to have a graph like this, and if I had a vector which is going that way, and if I were to say this point here, the terminal point has u1 comma u2, those are the terminal points, and we are representing a vector, and if this one here is length of the vector, and if I were to draw a line here, or if I were to project this point onto the x-axis, this is going to be magnitude u2, and this is going to be magnitude u1, and this is 90 degrees. Therefore we can apply the Pythagorean theorem here. Let me write that here. Applying the Pythagorean theorem, we can show that the length of the vector raised to the power of 2 is equal to the length of the sides of the right triangle, the square of the lengths of the sides of the right triangle. So the Pythagorean theorem states that the square on the hypotenuse is equal to sum of the squares on the other two sides. So that is exactly what we have written here. So we can also write this as vector u, the length of vector u raised to the power of 2 is equal to u1 squared plus u2 squared. And that is how we can use the Pythagorean theorem to find the length of a vector, length of the vector. Okay. Then let us also define the length of the vector in Rn spaces. How do we do that? Let me write that here. Definition of length of a vector. Definition of length of a vector in Rn spaces, and that is done as follows. If V is a vector, let's say if V is a vector in R2 spaces, and vector V has components v1 comma v2, then the length of the vector is given as the square root of the components, individual components raised to the power of 2 under the radical sign, v1 squared plus v2 squared under the radical sign, like that. Okay, then that is one. The second one is, if V is a vector if V is a vector in three spaces, let me write this clearly, in three spaces, the 3 is not coming out correctly, in three spaces, there we go, and if vector V, the components of vector V are V1, V2 and V3, then the length of this vector can be represented as follows. The length is written out as the square root of V1 squared plus V2 squared plus V3 squared. Okay. Similarly, if V is a vector in Rn spaces, and if vector V has components V1, V2, V3, all the way till Vn, then we can write the length of that vector as equal to the square root of V1 squared plus V2 squared plus V3 squared plus all the way to Vn squared, like that, right? So that is the way to find the length of the vector. The length of a vector is also called a norm. Sometimes the length of the vector is also called a norm. Let me write that here. Length of a vector is also called a norm. It is also called its norm. N-O-R-M, also called its norm. If the length of the vector is equal to 1, then vector V is called a unit vector. If the length of the vector is 1, then let me write that here. If the length of this vector is equal to 1, then vector V is called a unit vector. It's called a unit vector. And these are some of the definitions or some of the terms which we want to use moving forward into this type of discussion. In my next presentation, we shall look at some more examples and then see how we can find the length of a vector and solve some example problems.